Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so as shown in the previous video, what you have learned is about nodal analysis, where it need to be happen at the essential nodes, where it connected with 3 or more branch, right? And then you use your KCL. And if you still remember your mesh, you have what we call super mesh, right? What is super mesh? Super mesh is the current source in between 2 loops. So let's say you have mesh 1 and mesh 2. So when there is a current source between these 2 loops, you are going to exclude that one, right? So same with your nodal analysis, you have here what we call supernode. Okay, let's see how the supernodes works. Okay, as shown in the previous example of the nodal analysis, what you have is only the current source at the left and right. There are no voltage source inside your nodal analysis in the previous example. Okay, now what will happen when we add the voltage source? So let's say we have 2 cases here where your voltage source is added at one node only, either the most left or the most right, or your voltage source exists between what we call this node and this node. So as you know before, the below one is what we call reference node. Okay, this is the node which one is the essential node, node 1 and node 2. So node 1 and node 2, we call that one non-reference node. So when there is a voltage source connecting to both 1 and 2, there is a non-reference node. That will be another case that we call case 2. But for the first case, that is case 1, where the voltage source is connecting at the from one node to another reference node. Not like this, both are non-reference node. Okay. So let's see what's the difference between these 2 cases. Okay, case 1 is the voltage source at the reference node to the non-reference node. So this means that the most left here. So the reference is the below one, right? So it connected between the non-reference to the reference. So we call this one case 1. But how about case 2, where the voltage source usually is on the horizontal, where it got connected to the both non-reference node. So node 1 and node 2 are non-reference node. So this is what we call supernode. Okay, if you compare with the super mesh, your current source is connected between 2 loops. But your supernode, your voltage source is connected between 2 non-reference nodes. Okay, let's see the definition. What is supernode? Is formed by enclosing so it can be either dependent means by circle, voltage source, or this one is independent, but dependent is by the diamond, where it can depend either current or voltage. Both need to be a voltage source connected between 2 non-reference nodes, means it will not connect to the ground. So once it's connected to the ground like this is not supernode. So usually it comes out in the horizontal way, where let's say this is a 2 non-reference. So we call this one supernode. Okay, how you are going to solve this supernode? Remember the super mesh you need to exclude. Same here, you are going to exclude the voltage source and any element that is connected in parallel. So let's say this is super mesh. I just connect this with the understanding of the super mesh. So let's say you have R here. You're going not only exclude your current source, you're going also to exclude anything in series. But if it is super node, let's say you have a resistor in parallel with these supernodes, you're going to ignore this together. Okay? So, how you're going to solve this one? First, you need to identify which one is supernode. Second, the keyword is exclude. And then apply KCL. And then KVL at the supernode. So, let's see the properties. Okay, what is the properties of the supermesh? The voltage source in the supernode is not completely ignored. So this is not supermesh, this is supernode. Okay, so it's actually not completely ignored. So it provides only the constraint equation to solve the node voltage. So it has the supernode has no voltage of its own. So it requires both KVL and KCL. Let's see this example 12. Okay, first you need to identify is there any supernode. So what is supernode? Supernode exists between two non-reference nodes. So this non-reference node need to be essential nodes, means it need to connect more than 3 elements. So node 1 is connected to 4, 3 and 9. Node 2 is connected to 9, 2 and 6 ohm. So let's say we name here V1 and V2. So what we next, identify the reference node. So the below one is what we call reference node. And what you need to do next? Okay, this is a non-reference. This is also non-reference. So yes, 9 volt here is a supernode. Okay. So what you need to do at the supernode, you're going to exclude this one. Okay. And then next, you're going to apply KCL. So let's see what is the value of the KCL. So first you are going to do at which junction. So let's say at V1. So this is, let's say, I1. The below one is I2. And the left one is I3. So what will be the equation of the KCL? I1 plus I2 plus I3 is equal to 0. Now look at the I1. Remember the nodal I equal V high minus V low over R. So what is I1? V high here. Looking at this backward. So this is V high, this is V low. So V1 minus, what is the reference here? 0 divided by 0. But now you have 21 volt is there. So are you going to divide minus 0 or you need to minus 21? So remember, what is the rule of the current? Where you need to wait, let me get the pen. V high minus V low, but your V high is V1. Okay, your V low here, you have a voltage source here, so we can consider here is the low voltage. So become V1 minus 21 divide by what? Divide by the resistance 4. Okay, plus what is I2? Okay, looking at the current I2, what is the V high is V1 minus what is the lower voltage is ground, divided by 3 plus I3. Now at the I3, you have these supernodes, right? So I'm going to exclude this one. And then what you need to do, see what is the current at this next here. So let's say we name here is I4 and here is I5. So this equation doesn't stop here because you are having this supernode. So you need to continue here, become I4. Why this one is I4? Because you are going to exclude this supernode. Okay, plus I5 equal to 0. Now let's continue. What is I4? V2 minus 0 over 2 plus the last one is I5, that is V2 minus 0 over 6 equal to 0. So if you solve this one, you multiply by 12. So you can get here 3V1 minus 63 plus 4v1 plus 6v2 plus 2v2 is equal to 0. Then you can get 7v1 plus 8v2 is equal to 63. Equation number 1. Okay. So this is the KCL at where? At Supernode. Now you have two unknowns, so you need to have another equation. So that is step number 4, where you're going to have KVL at the Supernode. So now let's redraw back. So this is your Supernode, 9 volt. Okay. And here you have another voltage that is called V2. Here is V1. So you just need to make a loop equation here. So by having here KVL at the Supernode, what will happen? Starting from here. So it become minus V1 minus 9. Why minus? Omit the minus first. Plus V2 is equal to 0. So you can get here minus V1 plus V2 is equal to 9. Equation number 2. So when you combine this equation using your calculator, you can get your V1 is equal to minus 0.6 volts, which is the same here. And your V2 is equal 8.4 ampere. Okay. But you're not finished yet. The question asks, what is V, what is I? So look at this V. So this V is actually V1. That is minus 0.6 volt. Now what is your I? Where is the I given here? I is actually I4. So what is your I4 here? I4 is actually V2 over 2. That is 8.4 divided by 2. Then you can get 4.2 ampere. So that's how you solve for the Supernode. So remember, you need to exclude. While you exclude, you continue the current law to I4 and I5, and then you move forward to the KVL. Okay. So for the next example, we will discuss in the class, inshallah. Okay, see you in the class. Assalamualaikum. Okay, before I finish, for this 3 example we will discuss in the class. Now let's sum up everything for chapter 3. So you learn about nodal, you learn about mesh. When you're thinking about nodal, you go to the KCL. And when you're thinking about mesh, you go to the KVL, that is loop. Okay, so do you need to know both? Yes, you need to know how to use nodal, how to use mesh. So which is more efficient? It depends on the problem. So when you have a current source, what you need to do? It depends on which location of the current source. Then you can know how to tackle the question. Okay, so you will learn how to use this step by step with experience. So usually we most of the time we use nodal, but on exam I will specify which method to use, either nodal or mesh analysis. So if you look here, nodal analysis is about KCL, mesh is about KVL, where you have the mesh current. So the super condition comes when you have a current source. When you have a current source, how you can get your super mesh? Current source in between two loops, right? In between two loops. But voltage source in between two non-reference node, we call supernode. Okay, so you need to be able to identify what is super mesh, supernodes before you go to the more further analysis. Okay, so this is the summary. Supernode, this is the 4 steps. Where is the supernodes? This part. Super mesh, where is super mesh part? Here, where you're going to have exclude this one and make the big KVL. This one you're going to exclude this one and then make a big KCL from here until here. Okay, so when you do your nodal analysis, go to the reference ground. Remember, you need to be in essential node KCL and try to solve for mesh. You need to have the mesh current, the initial current, and then you apply your KVL.